all warmly welcomed on SLTV Lab.
Ladies and gentlemen, let's see how to determine the electrical axis of the heart. You may wonder, what is the electrical axis of the heart? Actually, the electrical axis of the heart is the direction of the depolarization of the ventricles. You know, ventricles are two big chambers of the heart. Now, the determination, or how to determine the electrical axis of the heart, is based on algebraic summation of what? Of the amplitude of the waves. You know, the waves are the deviation found on the electrocardiogram. So that constitute QRS complex. Do you get me? The summation of the amplitude of the waves that constitute QRS complex. I think you know the waves that makes QRS complex. Those are QRS waves. Now, for a wave under the zero line, which is electric line, you count it as a negative number of millimeters. Now, for a wave above zero line, count the positive number of millimeter and make an algebraic summation of those waves. Now, if the sum is negative, I mean the summation of the waves is negative, the vector will be oriented to the negative side of the reed. Now, if the sum is positive, then the vector line will be oriented to the positive side of the reed. Now, let's see how you can draw those leads just by using bipolar limb leads. You remember those limb leads are lead 1, lead 2, and lead 3. You draw a equilateral triangle. We call it Endhoven's triangle. Now, on each side, the zero is at the center of the side. So every side will represent a reed. Do you get me? Now, you have drawn your Endhoven triangle, the equilateral triangle. The next step is now to just put there the summation of the QRS waves, starting from the center, which is 0, the center of every side. Now, to draw the summation, use the appropriate scale that allows you to report QRS amplitude on the 3 sides. Now, how do you do it? Draw the vectors representing QRS amplitude on the 3 sides of the triangle. Every side represent the reed. There is reed 1, lead 2, and reed 3. You will use the same scale on every side. If you have taken like an example of using millimeters, you use millimeters. If you have taken the example of using centimeters, use centimeters on every side representing the reeds. The other thing, you have to respect the orientation of the vectors. The orientation means if the amplitude of QRS is negative, just draw the vector into a negative direction. If the amplitude of QRS is positive, now draw it into a positive direction. The next step will be to draw the perpendicular lines passing through the end of each vector of the 3. Those 3 perpendicular lines delineate a small triangle. Do you get me? If you draw those lines that are perpendicular to the end of each vector, those lines will make a small triangle. The next step now is to draw a horizontal line passing through the center of the grid triangle. Do you get me? Draw a horizontal line passing through the center of the grid triangle. The grid triangle is the other triangle, the equilateral triangle representing the reeds. Now you will draw the second line. That line will pass through the center of the grid triangle and the center of the small triangle. There is a horizontal line first that passes through the center of the grid triangle. Now this is the line passing through the center of the grid triangle and the center of the small triangle. The next step is measuring the angle between the other horizontal line and the line passing through what? The centers of the grid and the small triangles in degrees. You get me? You have to measure the degree or the degree of the angle between the horizontal line, the other line passing through the center of the grid triangle, and the line passing through the centers of both small and great triangles. Now, what is now cardiac or heart axis deviation? That degree, those degrees of that angle is the electrical axis of the heart. Do you remember which angle? The angle between the horizontal line passing through the center of the grid triangle and the line passing through centers of both grid and small triangles. So that angle between the two lines, that is what we call electrical axis of the heart. Now, geometric electrical axis of the heart can also be determined using augmented limb leads. You remember those are unipolar limb leads, AVR, AVL, and AVF. The first method was using the bipolar limb leads, lead 1, lead 2, and lead 3. Now we are going to use the unipolar or augmented limb leads. Good. Where are the three lines? A line is representing what? Representing the leads. Where those lines intersect, put 0. Then report the vectors representing the amplitudes of QRS on the 3 axes. Is that clear? The lines representing the unipolar or augmented limb leads intersect. Where they intersect, put 0. Then report the vector representing the amplitude of QRS on the 3 axes. Also, as on the bipolar limb leads, you have to respect the negative and positive orientation of the vector and proceed as we have done with the bipolar limb leads. So the next step is to conclude. How do you conclude? You have to indicate if electrical axis of the heart is normal or not. How do you do it? Depending in which quadrant it is. Like from 0 to 90 it is normal. From 0 to minus 90 it's left axis deviation. 90 to 180 it is right axis deviation. So from minus 180 to minus 90, it's extreme right axis deviation. Is that clear? 0 to 90, it's normal. 0 to minus 90, it is left axis deviation. 90 to 180 is right axis deviation. Minus 80 to minus 90, it's extreme right axis deviation. So at the end, here is the remark. Depending on body constitution or how the body is, small left deviation can occur. It means 0 to minus 90 degrees can be considered as normal. In which kind of people? In thick person, I mean obese or big person. And the small right deviation can occur like 90 to 120 can also be considered as normal in tall and thin person. This can happen.
Thank you for watching the video. I hope it's very helpful. So please don't keep this information just with yourself. Share this information to your colleagues. And see you in another video next time. May God bless you abundantly.
Please support this channel by pressing like, subscribe and the bell. This is a huge support for this channel. May God bless you.